Welcome to the class. This is the sixth class of basic electronics. Now today we are going to discuss about the power supply filters. The purpose of the power supply filters is to smooth out the ripple contained in the pulses of DC, which is obtained from the rectifier circuit while increasing the average output voltage or a current. The output of a rectifier consists of a DC component, also known as a ripple. The output of a rectifier consists of a DC component, which is known as a ripple. Ripple, especially a ripple voltage. In electronics, ripple ಅಂದರೆ ಏನು? ಏರಿಳಿತ. Ripple ಅಂದರೆ ಏರಿಳಿತ. Ripple, especially ripple voltage in electronics, is a residual periodic variation. ರೆಸಿಡ್ಯೂಲ್ ಅಂದರೆ ಏನು ಅಂದರೆ ಉಳಿದಿರುವಂತಹ ಅಥವಾ ಶೇಷಾತ್ಮಕ variation of DC voltage within a power supply which has been derived from an alternating current, that is AC source. The ripple is due to incomplete separation of the alternating waveform after rectification. Ripple is due to incomplete separation of the alternating waveform after rectification. The undesired AC component has a frequency of 100 Hz. That is double the supply frequency of 100 Hz, and it is called as ripple. It is the fluctuation superimposed on the DC component. The ratio of the RMS value of AC component to the DC component in the rectifier output is known as ripple factor. That is, ripple factor is nothing but RMS value of AC component, which we are regularly use as I of AC, this divided by value of DC component, that is I of DC. Therefore, ripple factor is very important in deciding the effectiveness of a rectifier. Remember this, a ripple factor is very important in deciding the effectiveness of a rectifier. Filter circuits. What is the meaning of a filter circuits? Why we are using the filter circuits in the power supply filters? So filters is a circuit which can be designed to modify, to reshape, or to reject all the undesired frequencies of an electrical signal and pass only the desired signal. Remember this, filters is a circuit which can be designed to modify, to reshape, or to reject all the undesired frequencies of an electrical signal and pass only the desired signal. In other way, we can say that an electrical filter is usually a frequency selective network that passes a specified band of frequencies and block signals of frequencies outside this band. So a rectifier is required to produce pure DC supply for using at various places in electronics or electronic circuit. However, the output of a rectifier has pulsating character. That is, it contains AC and DC components. The AC component is undesirable and must be kept away from the load. To do so, filters or filter circuit is used which removes or filters out the output, that is, it filters out the AC component and allows only the DC component to reach the load. So in electronic circuits, filters actually or filter circuit is used to remove the AC component and allows only the DC component to reach the load. Electronic circuit ನಲ್ಲಿ ಫಿಲ್ಟರ್ಸ್ಗಳನ್ನ ಅದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರಂದರೆ ಇದು ಫಿಲ್ಟರ್ಸನ್ನು ಎ ಸಿ ಕಂಪೋನೆಂಟನ್ನು ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಮತ್ತು ಡಿ ಸಿ ಕಂಪೋನೆಂಟನ್ನು ಲೋಡಿಗೆ ರೀಚ್ ಆಗುವಂಗೆ ಮಾಡಲಿಕ್ಕೆ ಉಪಯೋಗ ಮಾಡ್ತಾರೆ. ಎ ಫಿಲ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ ಇಸ್ ಅ ಡಿವೈಸ್ which removes the AC component of a rectifier output but allows the DC component to reach the load. Filter circuit must be installed between the rectifier and the load. Filter circuit is a combination of inductor and capacitor. A capacitor passes AC but does not pass DC at all. On the other hand, an inductor opposes AC but allows DC to pass through it. Remember this. An inductor opposes AC but allows DC to pass through it. In power supplies, capacitors are used to smooth out the pulsating DC output after rectification so that nearly constant DC voltage is supplied to the load. So you remember this, that is filter circuit, it's a combination of inductor and capacitor. Inductor opposes AC but allows DC to pass through it. Capacitors are used to smooth or filters the pulsating DC output after rectification. The following figure shows the functionality of a filter circuit. A filter circuit is constructed using two main components, inductor and capacitor. We have already studied in basic electronics, that is, an inductor allows DC and blocks AC. A capacitor allows AC and blocks DC. Now here you can see, suppose this is the output, a rectified output. So this is a pulsating DC. Here you can see. Now to convert this one as the ideal filter, that means to get a constant output, DC output like this, a straight line. It looks like a straight line. ಇಲ್ಲಿ ಪಲ್ಸೇಟಿಂಗ್ ಡಿ ಸಿ ಇತ್ತಂದರೆ, ಅಂದರೆ ಈ ಥರ ಏರಿಳಿತದಿಂದ ತುಂಬಿದಂತಹ ಡಿ ಸಿ ಇತ್ತಂದರೆ ಅದನ್ನು ಸರಿಸಮಾನವಾಗಿ ಅಂದರೆ ಒಂದೇ ಥರ ಇರುವಂಗೆ ಮಾಡಲಿಕ್ಕೆ ಉಪಯೋಗ ಮಾಡುವಂತಹ ಒಂದು ಸರ್ಕ್ಯೂಟ್ಗಳು, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ದಿ ಫಿಲ್ಟರ್ಸ್. ಇಲ್ಲಿ ಕಾಣ್ತಾ ಇರಬಹುದು ಏರಿಳಿತ ಆರಂಭದಿಂದ ವಿ ಎಮ್ ಅಂದರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ವೋಲ್ಟೇಜ್ ರೀಚ್ ಆಗಿ ಮತ್ತೆ ಕೆಳಗೆ ಬರ್ತದೆ, ಮತ್ತೆ ಇರ್ತದೆ. ದಿಟ್ ಈಸ್ ಏರಿಳಿತ, ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗುವಂಥ ವ್ಯಾಲ್ಯೂಗಳು. ಇದನ್ನು ಸರಿಪಡಿಸಿ ಒಂದು ಕಾನ್ಸ್ಟಂಟಾಗಿ ನಮಗೆ ಔಟ್ಪುಟ್ ಕೊಡಬೇಕು ಅಂದರೆ ನಮಗೆ ಇಲ್ಲಿ ಫಿಲ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ಗಳನ್ನು ಉಪಯೋಗ ಮಾಡಬೇಕಾಗ್ತದೆ. ಹಾಗಿದ್ದಲ್ಲಿ what are the types of filter circuits? The first one is the inductor filter. First one is the inductor filter. In inductor filter, it consists of a inductor connected in series with a rectifier output circuit. You remember this. ಇಲ್ಲಿ ನೆನಪಿಟ್ಕೊಳ್ಳುವಂಥ ವಿಷಯ ಏನೆಂದರೆ ಇಂಡಕ್ಟರ್ ಏನಿದೆಯಲ್ಲ ಫಿಲ್ಟರ್ನಲ್ಲಿ ಸೀರೀಸ್ ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾರೆ. ರೆಕ್ಟಿಫೈಯರ್ ಔಟ್ಪುಟ್ಟಿಗೆ ಸೀರೀಸ್ನಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾರೆ. ಆ್ಯಂಡ್ ಕೆಪಾಸಿಟರ್ ಕನೆಕ್ಟೆಡ್ ಇನ್ ಪ್ಯಾರಲಲ್. ಕೆಪಾಸಿಟರ್ನ ಪ್ಯಾರಲಲ್ ಆಗಿ ಔಟ್ಪುಟ್ಟಿಗೆ ಅಂದರೆ ರೆಕ್ಟಿಫೈಯರ್ ಔಟ್ಪುಟ್ಟಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾರೆ ವಿತ್ ದಿ ಲೋಡ್ ರೆಸಿಸ್ಟರ್. ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಎಲ್ ಸೆಕ್ಷನ್ ಫಿಲ್ಟರ್ because the inductor and capacitors are connected in the shape of inverted L. The output pulsating DC voltage from the rectifier circuit passes through the inductor or choke. The inductor has a low DC resistance. You have to remember this. The inductor has low DC resistance and extremely high AC reactance. Thus, ripples get filtered through choke. Some of the residual ripples, if present in filtered signal from the inductor coil, will get bypassed through a capacitor. ಇಲ್ಲಿ ನೋಡಿ, ripples get filtered through choke. Some of the residual ripples, if present in filtered signal after inductor, will get bypassed through the capacitor. ಚೋಕಿನಿಂದ ರಿಪ್ಪಲ್ ಯಾವುದಾದರೂ ಫಿಲ್ಟರ್ ಆಗದೇ ಇದ್ದಲ್ಲಿ ಅದನ್ನು ಕೆಪಾಸಿಟರ್ ಅದನ್ನು ಫಿಲ್ಟರ್ ಮಾಡ್ತದೆ. ಮ್ಯಾಕ್ಸಿಮಮ್ ರಿಪಲ್ಸನ್ನು ಅಂದರೆ ಏರಿಳ್ತಾ ಇರುವಂತಹ ಒಂದು ಸಿಗ್ನಲನ್ನು ಹೆಚ್ಚು ಕಡಿಮೆ ರಿಪಲ್ಸನ್ನು ಚೋಕ್ ಫಿಲ್ಟರ್ ಮಾಡ್ತದೆ. ದ ರೀಸನ್ ಬಿಹೈಂಡ್ ದಿಸ್ ದಟ್ ಇಸ್ ದ ಕೆಪಾಸಿಟರ್ ಅಲೌಸ್ AC ಆ್ಯಂಡ್ ಬ್ಲಾಕ್ಸ್ DC. Although the inductor efficiently removes AC ripples, a small percentage of AC ripples is still present in the filtered signal. These ripples are then removed by the capacitor connected in parallel to the load resistor. Now the DC output signal is free from AC component, and this regulated DC can be used in an application. If the inductor of high inductive reactance XL greater than the capacitive reactance at ripple frequency is used, then the filtering efficiency gets improved. ಯಾವ ಥರ ಇದು ವರ್ಕ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ ಈಗ ನೋಡಿ. ಸಪೋಸ್ ವಿ ನೋ ದ್ಯಾಟ್ x of L is equal to 2 pi FL. XC is equal to 2 pi FC, that is 1 divided by 2 pi FC. We know that XL is equal to 2 pi FL, XC is equal to 1 divided by 2 pi F of C. If frequency is 0, if the frequency is 0, then XL becomes 0. That means there is no resistance here. There is no resistance. If the frequency is higher, it is infinity here, then XC will work as an open circuit. We know that frequency of DC is 0. For DC, XL will be work like a closed circuit. For DC, XL will work as a closed circuit and capacitor will work as a open circuit here, because XL is much greater than XC. When XL is much greater than XC, almost all AC voltage is drops across choke. You remember this? When XL is much greater than XC, the value of the inductor is much more than the value of the capacitor. Almost all AC voltage is drops across choke. ಯಾವ ಒಂದು ಸಮಯದಲ್ಲಿ ಇಂಡಕ್ಟರ್ ವ್ಯಾಲ್ಯೂ ಕೆಪಾಸಿಟರ್ ವ್ಯಾಲ್ಯೂಕ್ಕಿಂತನೂ ಹೆಚ್ಚಿಗೆ ಇರುತ್ತದೆಯೋ ಅಂಥ ಟೈಮಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಎ ಸಿ ವೋಲ್ಟೇಜ್ ಏನಿದೆಯಲ್ಲ ಅದು ಚೋಕ್ನಿಂದಲೇ ಫಿಲ್ಟರ್ ಆಗ್ತದೆ. ಇಟ್ ಡ್ರಾಪ್ಸ್. ವೆನ್ ಇನ್ಪುಟ್ ಟು ದಿ ಚೋಕ್ ಈಸ್ ಎ ಸಿ, maximum drops comes across choke and the remaining drops comes across capacitor. ಒಂದು ವೇಳೆ ಚೋಕಿನಿಂದನೂ ಸಹ ಫಿಲ್ಟರ್ ಆಗದೇ ಇರುವಂತಹ ಕೆಲವೊಂದು ಎ ಸಿ ಸಿಗ್ನಲ್ ಇದ್ದರೆ ಅದು ಕೆಪಾಸಿಟರ್ ಅದರ ಮುಂದೆ ಕನೆಕ್ಟ್ ಇತ್ತಂದರೆ ಆ ಕೆಪಾಸಿಟರ್ ಅದನ್ನು ಡ್ರಾಪ್ ಮಾಡುತ್ತೆ. And the remaining drop comes across capacitor, because capacitor value is lesser than the inductor. So let us go for a small equation. Salpagi nodkonna. V out is equal to x of c into VIN divided by XC plus XL. As XL is greater than XC, ಅವಾಗ ಏನಾಗ್ತದೆ? What is going to happen? V out equal to XC divided by XL, this into VIN. Because the value of XC is much lesser than the XL, therefore we are going to neglect this a little bit. So V out is equal to XC by XL into VIN. ಅವಾಗೇನಾಗ್ತದೆ? What is going to happen here? Once the AC component enters into the inductor filter, which is connected in series to the rectifier output. The rectified output, when passed through this filter, the inductor blocks the AC components that are present in the signal in order to provide a pure DC. This is a simple primary filter, because you know that if in XL 2 pi FL XC is equal to 1 divided by 2 pi FC, if the frequency is 0, then XL becomes 0. That means there is no resistance, so it will work as the closed circuit. So go for the second one, that is called a capacitor filter. As a capacitor allows AC through it and blocks DC, a filter called shunt capacitor filter. A typical capacitor filter circuit is like this. This is the capacitor which is connected. This is a capacitor which is connected in parallel. So here you can see inductor is connected in series to the rectified output. Capacitor is connected in parallel. The designing of this circuit can be done with a capacitor as well as the load resistor. The rectifier's voltage is given across the terminals of the capacitor. Whenever the voltage of the rectifier enhances, then the capacitor will charge as supplies the current to the load. At the last part of the quarter phase, the capacitor will be charged to the highest rectifier voltage value, that is denoted with V of M. And then the voltage of the rectifier starts to reduce. As this happens, the capacitor starts discharging through the voltage across it and the load. The voltage across the load will reduce little only because the next peak voltage occurs simultaneously to charge the capacitor. This procedure will repeat many times, and the output waveform will be seen that very slight ripple is missing in the output. Furthermore, the output voltage is superior because it remains significantly close to the highest value of the output voltage of the rectifier. At the last part of the quarter phase, the capacitor will be charged to the highest rectifier voltage, that is denoted by V of M, and then voltage of the rectifier starts to reduce. As this happens, the capacitor starts discharging through the voltage across it. Now why again the capacitor is used? Capacitor usually used to filter the AC component which is present in the rectifier after the rectifier circuit. The signals which is coming out from the rectifier circuit is a pulsating like this. Now here is the output, filtered output of the capacitor. How it works actually? If I connect here a capacitor, say this is positive, this is negative. Suppose I am supplying 3 volts here. 3 volt at this corner. Now if I divide this into 3 equal parts, say this is 1 volt, say this is 2 volt, say this is 3 volt. So the output of the rectified circuit is say 3 volt. When this 3 volt enters into the capacitor like this, the potential difference created between these two plates is 3 volt. The capacitor is going to get charged when the potential difference is a 3 volt. So up to here, say this is up to 1 volt, it is getting charging and it passing through like this. When it comes to the 2 volt, again this is going to get charged and the same amount is going through this. When it comes in a downward direction like this. So here you can see when it comes from 3 volt to 2 volt, Here it is. Here. So the lack of 1 volt. So in this time, the capacitor pass through its charges to the circuit. So you are going to get this type of waves. Here you can see. The same way, it is continuous. It is getting charge, discharge, charge, discharge. So this is the continuous process. So this can help actually to reduce the ripples which is present after the rectifier circuit. The capacitor gives an infinite reactance to the DC. For DC, we know that frequency is 0. So X of C, we know that is 1 divided by 2 pi Fc. That is 1 divided by 2 pi into 0 into C, that is infinite. Therefore, the capacitor does not permit DC to flow through it. The rectified output, when passed through this filter, the AC components present in the signal are grounded through the capacitor, which allows AC components. The remaining DC components present in the signal are collected at the output. So next we can go for a combination of L and C filters. A filter circuit can be constructed using both inductor and capacitor in order to obtain a better output where the effectiveness of both inductor and capacitor can be used. So the figure below shows the circuit diagram actually of a LC filter. So this is the inverted form of a L. Inverted form of a L. So here the rectified output, this is the rectified output. If I consider this as the A and B, if this is the rectified output, now the inductor is connected in series to the output and capacitor is connected parallel to the circuit. So some part of the ACs get filtered from the L inductor and the remaining is going to get filtered from the C. A filter circuit can be constructed with both inductor and capacitor in order to obtain a better output where the effectiveness or the efficiency of both inductor and capacitor can be used. A filter circuit can be constructed using both inductor and capacitor in order to obtain a better output where the efficiencies of both inductor and capacitor can be used. So what is our main intention to design the filter is to get a better output. So the better output means where I am going to get output as a constant. This is an ideal filter output. Our aim is to obtain an ideal filtered output where it looks like a straight line. So maximum we are trying to get this line, a straight line. The rectified output when given to this circuit, the inductor allows DC component to pass through it, blocking the AC components in this signal. The inductor allows DC components to pass through it, blocking the AC components in the signal. So we know that is, this is because of when I say XL equal to 2 pi FL, the frequency here, if the frequency is 0, XL becomes 0. That means there is no resistance. So in this case, the inductor allows the DC components to pass through it and blocking the AC component in the signal. Now from that signal, few more AC components, if any present, are grounded so that we get a pure DC output. So this filter is also called choke input filter, as the input signal first enter the inductor. The output of this filter is a better one than the previous one. Instead of using a single filter which consists of an inductor or a capacitor, a combination of L and C filter is better. Now here we have another type of a filter which is known as the pi filter, which looks like a pi. This is another type of filter circuit which is very commonly used. It has a capacitor at its input, and hence it is also called a capacitor input filter. Here two capacitors and one inductor are connected in the form of a pi-shaped network. A capacitor in parallel, then in inductor in series, followed by another capacitor in parallel makes this circuit. So here you have to remember this. Inductor is always connected in series, capacitor or capacitors always connected in parallel. If needed, several identical sections can be added to this according to the requirement. So here you can see an output of a pi filter which looks like an ideal filter output, which looks like a straight line. So here in the circuit we have the capacitor in parallel, then the inductor in series, followed by another capacitor in parallel. So the capacitor 1. This filter capacitor offers high reactance to the DC and low reactance to AC signal. After grounding the AC components present in the signal passes through the inductor for a further filtration. Inductor EL. This inductor offers low reactance to DC components while blocking the AC components, if any that is managed to pass through the capacitor C1. Capacitor C2. Now the signal is further smoothened using this capacitor so that it allows any AC component present in the signal which the inductor has failed to block. So thus we get the desired pure DC output at the load.